What's up, guys? We're talking about T.4 and IXL for Algebra 2, which is solving exponential equations. Right now, you guys are viewing take 2 of this. I don't know why my pen tool for writing on the screen is getting thrown all out of whack. I think I got it figured out, at least to a usable extent, but I guess we'll see as we go and if you guys even see this one. Solving exponential equations being the goal, that means solving, we're going to get a value at the end, or x equals something, y equals something, whatever a variable is. Exponential means that variable is going to be in the exponent, and then equation meaning we're going to have that nice equal sign in the middle. Our goal for this, especially if you've been in my class to kind of have me teach this to you in person, we've been talking about this as a three-step process, meaning we want to make the base numbers match. So in this case, that'd be like the 1 and the 7 matching. If need be, simplify the exponents. Usually that's multiplication, maybe distribution. Third one, set the exponents equal to each other. So let's go through this one and see what we end up with. We'll try to keep this one fairly short. So something that we need to remind us of is that we can change 1 to a base to the exponent of 0, and that'll be equal to each other. So in this case, if I want a 7, that's the same thing as, or if I want a 1, that's the same thing as 7 to the power of 0. Let me write that a little bit neater. And still, my screen's off here. I'm still a little unsure what's going on. There we go. I'll just make it really big. I think that helps. Equals, and then on the other side, I have 7 to the power of x. There we go. I think I just need to slow down. In this case, I have no distribution or anything like that in the exponent, so I can go to step 3, set the exponents equal. So on the left side, that's a 0, equals, and then on the right side, I have an x. So x must equal 0. Let's try that and see what we get. So anytime you need to change a 1, you can make it whatever base you need to the power of 0. Awesome. So this would be a similar one here. Let's jump forward, though, and see if we can't find something different. So in this case, you would still change that to 8 to the power of 0. You would just need to solve. Let's look at one that uses kind of a couple different twists. Let's see. I would like to talk about something like that, but we'll see. Okay, it wants us to do this one. Let's see what we get. So I need to make the bases match. Right now I have an 8 and a 1/8. Another rule that we can try to remember is that to get something from the bottom of a fraction to the top, or vice versa, I could give it a negative exponent. So if I leave my left side alone as 8 to the power of 2x equals, instead of 1 over 8 to bring that 8 to the top, I would write 8 to the power of negative 1, and that would be the same. If down here this was like 8 to the power of 2x, I would make it negative 2x, and that brings it to the top. Now, I still don't have anything extra to distribute up here, so I can jump to my third step of setting the exponents equal. 2x equals negative 1, and then solve for x. So if I divide both sides by 2, I would get x equals negative 1/2, or 1 over 2. I think that's out of the screen a little bit for you guys there. There you go. And then that would be our answer. So that's kind of the process to take away here. Let's go ahead and type that in, negative. You can use this button, but I believe you can also just type 1/2, and that should work too. Let's see. Fantastic. Okay, let's look at something like this one. So this is a little bit more tricky. So off the top of my head, I'm trying to make the bases match, and usually it's going to be nicer to take the bigger number and make it match the smaller one. So like take the 256 and make it 64 to some power. But right off the bat, if I go, I'm not good with exponent 64 to some power off the top of my head, but if I go to the calculator and try even 64 squared, that's too big. It's not 256. So I have to use another option. Something I can do is rewrite both as some smaller base to some power. I see that they're both even, so I'm going to try the power or the base of 2 to some power. So after a few seconds of trying in the calculator, if this is something you cannot think of off the top of your head, I could find that 64 is the same as 2 to the 6th, but I would still have that x plus 1. Got to tell myself, slow down when I'm writing here, equals. And then if I try to get to 56, that would be 2 to the 8th power, 2 to the power of 8. Now, this is an instance I am going to have that second step of I need to simplify this, a power to another power's multiplication. And since I have multiple terms out here, that's going to be distribution. So what I'm going to end up with is 2 to the power of 6 times x is 6x. And then 6 times 1, that plus 1 out there is going to be a 6, equals, the right side doesn't change at all in this one. Now I can make the exponents, now that they're simplified, now that they have the same base, I can set them equal. Let's do that off to the side so I have more room. 6x plus 6 equals 8. If I subtract 6 from both sides, I'm going to end up with a 6x, and 8 minus 6 is 2. Now if I divide both sides by 6, I get x equals 2 over 6, but 2 over 6 can reduce to 1 over 3. And if I look at the directions here, it wants fraction in simplest form. So that's why I go from 2 divided by 6 to 1 divided by 3. Again, I should be able to, if you want to use this, you can, but you could also type in 1/3. Should be fine there. Fantastic. Okay, let's do this as one more. Well, let me jump ahead and see if there's anything different. About the same, fraction with an exponent. Okay, so let's do this one. 1 over 16 to the power of 4x. Well, right off the bat, I want to change that so that the 16 is not in the bottom of a fraction. So if I make that negative, like our rule from before, I could have 16 to the power of -1. Let me make this a bit smaller and scroll down so I have more room. 16 to the power of -1, and then I still have that 4x on it. And then on the other side, I have a 2, technically 2 to the first power if you want to see an exponent there. Now that I see 16, I want my bigger number to match my smaller one. So I need to think 2 to what power gives me 16? That would be the 4th power. So I can rewrite that left side as 2 to the 4th power, and then to the power of -1, and then another layer here to the power of 4x. Although it looks like a lot, it's not going to end up being so bad because they're all just going to multiply together. So it's not going to change too much. 4 times -1 is -4, and then -4 times 4 is -16. So I'm going to have 2 to the power of -16, and it keeps that x on there. So you just got to be careful and keep track of all your layers, but once you do that, they all multiply together. Third step, now that I have the same base and I've multiplied, I can set those equal. Let's do that off to the side again. -16x equals 1. Well, I need to divide both sides by -16 to get x by itself. And I would get -1 over 16. So let's go ahead and put that in and make sure we're on the right track, and then we'll wrap up. Fantastic. Okay, so now we're past that 85. These rules stay the same. Negatives to get rid of fractions, layers of multiplication like something on the right side there. So once we can tie all those in together, we'll be on the right track. Okay, we'll wrap up here. If you found this helpful, leave a like. Feel free to subscribe. We'll see you guys.